Okay, in today's video, we're going to walk through the calculations for the Kinetics methylene blue with ascorbic acid lab. So I have on the right-hand side the calculations instructions, and then on the left-hand side I have an Excel spreadsheet. So you can use Excel spreadsheet or some other spreadsheet that you have access to. So for the first video, we're only going to be focusing on number 1 and number 2 from the calculation section, and then on the second video we'll focus on 3 and 4. So 1 and 2 will be like day 1 and 3 and 4 will be day 2. However, if you want to watch both videos on one day, that is no problem. Okay, so the first part of the calculations say that you are going to be doing a lot of graphs. Yes, that's true. You are going to be doing a lot of graphs. So let's just start with number 1. It says calculate and record the absorbance minus absorbance infinity values for each data point taken. So let me give you an example of what that looks like. So what I've done is I've left some room at the very top of my Excel spreadsheet so I can do basically the final calculations as well as all of the calculations in regards to molar concentrations. I think that's more helpful to have them at the top. So if you want to start your sample data at row 13 or so, then that will give you plenty of space at the top to have your final values stated at the very beginning. So this is an example of what your first run may look like. So I have a column for time, and then I have a column for absorbance. You could also just do it like this, time in seconds, so that you know, oopsies, so that you know what the units are that we're using. And then remember, absorbance doesn't have units. It's just basically a fraction of the total light that's coming through the sample. So here's absorbance. And then the last column, and this is really what you are going to be plotting, is the natural log of A minus A infinity. We'll talk about that in lecture, but essentially when you take the natural log of reactant concentration on the y-axis and then plot it against time on the x-axis, you will get a straight line as long as that reagent or that reactant is first order. And what we're basically plotting is the concentration or the natural log of the concentration of methylene blue versus the time elapsed in the experiment. And we are assuming that methylene blue is a first order reaction, which you'll see when you plot your data, you get essentially a straight line, which tells you that it is indeed approximately a first order reactant. So you might be thinking, but wait, we're plotting absorbance, not concentration. But you should know from Beer's law, which is A is equal to, and this is going to be abbreviated, but epsilon L times concentration, that concentration and absorbance are directly proportional to each other. So the rate of change in one is going to be the same as the rate of change in the other one. Okay, so this is what you're going to do first, and I will tell you within this video when to pause and to insert some data and then move on to the next point, because some of this is just going to take time for you actually to input your data. So input all of your time measurements. For the first run, you likely have more data than you do for the third, fourth, and fifth run, etc., because the later runs went a lot quicker than the first run did. So just write all the time values that you do have down. Mine are going to be looking a little bit different than yours. I think mine are measured about every 30 seconds or so instead of every 15 seconds, but you write down what you have, and then all of your absorbance values are going to be right here. At the very bottom, I put A infinity, and then I put the A infinity value right next to it. So I want you to go ahead and pause, and you can do that for your first sample. If you'd like to do all your samples, that's fine as well, but I think that will take a little too much time to do. So go ahead and pause and do the first sample, and then once you're finished inputting that data, come back and see how I calculate the natural log of A minus A infinity. Okay, so glad you're back. Hopefully you got all those values in. How did I actually calculate this column? Well, you can do it by hand. You could take A, so this value, minus A infinity, which is this value, and then take the natural log of that answer. You could also do it in Excel, which is a lot easier, and it looks something like this. So you're going to put the equal sign, and that's telling Excel that you are going to perform this function. you're going to solve whatever you put after the equal sign. And then you're going to put ln, and then it'll pop up whatever function you want to use. So I'm going to click natural log. And then I want to take my initial absorbance value, which in this case is 0.438, and then subtract from it my A infinity value. There's several ways you can do this, but I think because this number is going to be staying the same all of the time, the easiest way to do this is just manually type in the number 0.006. You can use the Excel function in which you use the $sign, if you know what I'm talking about, to keep that cell the same for every calculation. But if you aren't familiar with what I'm talking about, then just manually type in your A infinity value, whatever you got for sample 1 or for run 1. Then you can press enter and it will give you this number right here. Well, if you have the same data, it'll give you that number. If not, you'll get something similar. And then all you have to do is click and drag this bottom right-hand corner square. So I'm clicking on it right now, and then I'm dragging until my final data point, and then notice it calculates all those values for me. When you do it in Excel, as opposed to maybe on a scientific calculator, you'll likely get more decimal places, which shouldn't drastically change your trend line anyway. But notice that this number, I have more data points than I do on this number. Okay, so go ahead and take a minute to do that. Pause the video and then come back. Okay, so next step, and I'm looking at the Kinetics Lab instructions, it says plot natural log of A minus A infinity on the vertical axis and then time on the horizontal axis. So you'll need to do this for each of your runs. And again, I'm just showing you an example of the first run, but you will have 6 of these graphs. Okay, so how do you actually get a graph that looks something like this? Well, first I'm going to highlight all of my time, and then I'm using a Mac, so I'm going to press Command and then click and highlight all of my natural log of A minus A infinity. There is an equivalent key for you to press if you're using a PC. It might be Option or Control or something like that. But what the Shift command does is it highlights everything from the cells that you just highlighted to the cells that you are currently highlighted. So this middle column would also be highlighted, which you don't want. And then you're going to go into Insert, move this over, Insert, and then you're going to choose a scatter plot. So it'll look something like that. Insert and a scatter plot. Okay, go ahead and do that. Now, how do I get these labels right here on the y-axis and x-axis? If you are under, let's see, let me kind of expand this a little bit. If you're under chart design, so mine is chart design, every Excel version has a little bit different layout, so just be aware of that. Google is your friend. Some type of internet search is your friend in this instance because you can pretty much look up any version of Excel or some equivalent spreadsheet and ask, how do I insert axes labels? And there will be an example for that. So don't rely on just asking me for answers. Go and look for yourself and you will find that there's information out there. Okay, and then you will click on Add Chart Element if you want to add axes titles. There's an example there. And I'm not sure, sometimes it seems when I record videos on Excel you cannot see these options. I think you'll be able to see these options, but if you don't, just know that sometimes that is an issue. So there's a drop-down menu, and then you can add a primary horizontal and vertical axes title. And then in that, make sure that on your x-axis, not only does it say time, but it also has the unit associated with the time. And then on the y-axis, it is the natural log of A minus A infinity. In addition, for chart elements, you can also add a trend line. So this is going to be a linear relationship. So you will click linear, and that will add a line for you. Okay. After that trend line is added for you, make sure again you have your axes labels and you have your chart heading. It needs to be detailed enough that we know what run it is associated with and the order of this plot. So this is a first order plot. You could also add something about methylene blue. It can be your own title. Just make sure it is detailed enough, but I don't need a paragraph at the top. Okay, so then we want to put we don't really need our R squared value. It's nice to know that it's a relatively good fit. R squared as close to 1 as possible is a better fit and just tells you that the data do align with a linear relationship. But what's really important for you to have is the equation of the line. So right-clicking on that line and then clicking on Format Trend Line, you'll see an option come up in which you can display equation on the chart, okay, which I already have. It just displayed it again. And then you can also display R squared value on the chart. But you definitely want to click this, display equation on the chart. And then you should get a negative slope because it should be going down. And then obviously your y-intercept. Okay, that's the same thing that you're going to be doing for each of the 6 runs. So let's make sure that we checked all the boxes in the calculation section. Let's see. Okay, so if you use Excel to make the plots, you can add a trend line. This will give you the fit line determined by linear regression. You can also tell the program to show the equation for the line. This gives you the slope directly, which we did. We got the slope directly. The slope of the natural log of a minus a infinity versus time is equal to negative k observed. That's essentially your observed rate constant. Your rate constant is going to be a positive value. That's why there's a negative in front of that k. So note, it is important to be critical of your data. They should give you close to a straight line. If they don't, double check that you have values correct. It is easy to transpose numbers. Okay. So if you do see something odd and you see your line, it's not quite a line, it looks like a curve, something like that, then there could be a problem with your calculations. Okay, but if there's something that shows that you did all of the calculations correctly and you still don't have a line, that may mean that you just have really bad data. Because remember, the pipetting for this experiment was really crucial to actually getting good data. Okay, so make a note of that if you don't really have a line, and then you'll use it in your discussion section to talk about what possibly went wrong. Okay, so you can pause here as well and make sure that you're finishing out your plot. If you want to do all your plots now, again, that's fine. But we are going to move on to number 2. Okay, what does number 2 say? It says, determine the concentrations of H plus and AA used in each experimental run by taking into consideration the initial concentrations of the stock solution and the dilution you did when making the reaction mixtures. So I'm going to look at this table right here. And I want you to also be aware that this table is here. That does include most of the concentrations. Your concentration for hydrochloric acid is not exactly 0.5. You wrote down the concentration depending on what section you're in. It was different depending on if you were on my Monday, Wednesday section or my Tuesday, Thursday section. So just make sure that you're using the value that you wrote down. But these 2 tables are going to be what you will be using for this section. Okay, let's start with HCl. So what I have set up here is I have run, and then I have my 6 runs underneath. And then I have HCl. This is, don't worry about this blank. It was just because I deleted something. Then I have methylene blue and AA for ascorbic acid. Okay, so at the very top, this shows you the calculation I used to get HCl. I'm going to do that same calculation right next to it, just so I can walk through it step by step with you. So how do I calculate the concentration of HCl based on the dilution that I did to get basically my initial concentration of HCl before the reaction occurred? So what I'm going to write up top is the formula. Remind you the formula we're using. It's just M1V1 equals M2V2. So that means I'm looking for M2. You know, what is the molarity just before the reaction occurred? After mixing, but before the reaction occurred. So that means if I want to solve for M2, I would have M1V1 over V2. So I need to find my initial molarity, my initial volume, and then divide it by my final volume. Okay? So let's do that right here. So we're going to press equal to, and then we're going to do my initial molarity. What's my initial molarity for HCl? So again, it depends on what section you're in, but I'm going to look at, I don't want to do that. I'm going to look right here, and I think the molarity for one of my sections was 0.497. It was supposed to be close to 0.5 molar, so 0.497. Oops. So I'm going to click this cell again, equal 0.497, and I'm going to multiply that by what my initial volume was. So I'm just looking at run 1 for HCl. So run 1 for HCl was 8 milliliters. So I'm going to plug in liters and close the parenthesis. I'm multiplying those two by each other, and then divide it by my final volume. So the final volume for for run 1 was 6.70 plus 8 plus 3.30 plus 2. So that's 20. All of the final volumes for each run is 20 milliliters. So I'm going to divide it by 0.02. Okay, so 0.497, or whatever the molarity was that you used, multiplied by your initial volume, which in this case was 8 milliliters, divided by total volume. Press enter, and that's what you get. That same number. So notice for run 2 and run 3, we have the same exact value for your initial molarity before the reaction occurred. And that's because you use the same volume, right? In run 1, 2, and 3, you have 8 milliliters. So keep in mind that that number is going to stay consistent, but it does change for run 4, 5, and 6. Okay, go ahead and take a minute to calculate HCl. Pause the video, and then I will show you just one more example for ascorbic acid. Okay, for ascorbic acid, remember that you have two different concentrations that you're dealing with. So run 1 and 2, oopsie, didn't mean to do that. Where are we? Cancel. Run 1 and 2. Notice that this right here is the initial molarity, 0.02. See right here, run 1 and 2, 0.02. But sometimes I hate that Excel does this. Hold on. Okay. But for run 3 through 6, the molarity is different. So this is my final answer, but make sure to use the molarity that is 0.20 for calculating molarity of ascorbic acid. Okay, and the last thing that I'll note about concentrations is that the original concentration of methylene blue is given up here. So when you want to calculate what the final, what the concentration after mixing is, but before the reaction occurs, then you are going to use this concentration and use the volume that is used for each run. And that's what I did to calculate these values over here for methylene blue. So before you're totally finished with this video, the last thing that you should insert is your K observed values. Now remember, I'm going to scroll down again. In the calculation section, it says that the slope that you got for each one of your runs is negative K observed. So again, that's your observed rate constant. So what I'm doing is I'm just looking at my slope right here, negative 0.0037, and I'm writing it directly for run 1. And then for run 2, wherever my graph is, I'm looking at that slope, and then I'm plugging in right here. So you want to have all these values plugged in before we do our calculations for 3 and 4. Okay, I hope that was informative. Let me know if you have any questions, and then I'll have the second video up for you to try soon.